In this video, I will walk you through some College Board multiple choice questions pertaining to change in tandem. That's how two quantities change together. This is AP Precalculus Topic 1.1. If you appreciate this content, please give it a like. Number 1. A ball is thrown through an open window to the ground below. The height of the ball in meters at time t seconds after it is thrown can be modeled by the function h, given by h of t equals this. Which of the following describes the height of the ball above the ground? This problem is calculator active, so let's go ahead and enter this equation as y1 in our graphing calculator. You want to hit the y equals button and type in the equation just like this. Notice that we have to use x instead of t, and for a negative sign in the front, make sure you used this negative, not this minus. Options A and B mention a maximum height of 15.240 meters, while options C and D mention a maximum height of 16.228 meters. So let's go back to the graphing calculator and find the maximum height. We will need to adjust the window a little bit. So hit the window button, and the height is going to be given by the y max. Right now we have a y max of 10, but the two options mentioned maximum height of 15 point something and 16 point something. So the y max needs to be bigger than 16. So let's make it, let's say 20. The ground is at 0, so it's not going to go negative. So let's go ahead and let the y min be 0 while we let the y max be 20. And let's go ahead and hit graph and see what happens. Okay, so that's a pretty good picture. Let's change the x values of the window. We are starting from 0, so x min doesn't have to go into the negative number, so we will let x min be 0. And we see that we're hitting the ground somewhere between 2 and 3 seconds. So let's let x max be 3 seconds. So hit the window, x min will be 0, x max will be 3. And hit graph again, and now that is a perfect picture. So we wanted to find the maximum height of the ball. So we will hit second trace and choose the option that says maximum, option 4. You can either scroll down to it or you can just hit the number 4. It's going to say left bound and then later right bound. When it says left bound, move the pointer to a place that is to the left of the max. So here's fine, and hit enter. Now it says right bound, so move the pointer to the right of the max and hit enter. Then it says guess. Move the point to about where you think the max is. And hit enter. So we have a max of 16.227 or 228. That's what we see in options C and D. So we've narrowed it down to either C or D. Option C says the height of the ball decreases until it reaches the ground 1.820 seconds after reaching its maximum height. On the other hand, option D says the height of the ball decreases until it reaches the ground 2.269 seconds after reaching its maximum height. So let's figure out how many seconds does it take for the ball to reach the ground after reaching its maximum height. The calculator forced us to use an x instead of a t, but this x coordinate is really the value of t, the number of seconds after the ball was thrown. So the ball reaches its maximum height of 16.228 meters at 0.4489808 seconds. Record that on your paper like this. Now let's find the time t when the ball hits the ground. We need to find the time when the height of the ball is 0. In other words, we need to find this x-intercept. There are two ways to do it. We can either hit second trace and use the 0 feature, or my favorite option is to graph the x-axis itself. So I'm going to put in a 0 on another equation. So let's put 0 right here and just hit graph. So this red line is the x-axis. Now the x-intercept will just be the intersection between the curve and this red x-axis. So we can hit second trace, intersect, option 5, and just move your pointer close to that point of intersection and hit enter 3 times. Enter, enter, enter. So the ball will hit the ground at 2.2688 seconds. We just found the time when the ball hits the ground. This is approximately equivalent to the 2.269 that we see in option D. However, you have to be careful here. Option D does not say that the ball hits the ground at time 2.269 seconds. It says the ball reaches the ground 2.269 seconds after reaching its maximum height. The ball reached maximum height at t equals 0.44898 seconds. The ball hits the ground at t equals 2.2688 seconds. To find how long it took for the ball to reach the ground after reaching its maximum height, we need to subtract these two values. The ball hits the ground 1.81982 seconds after reaching maximum height, or 1.820 seconds. So the answer is C. Number 2, the table above describes rates of change of a function f for selected intervals of x. Part A. On which interval is f increasing and the graph of f is concave down? Please memorize this chart showing the graphical relationships between a function f, its rate of change, and the rate of change of the rate of change. This will come up over and over again in AP Precalculus and in AP Calculus. I recommend that you write this chart on a piece of scratch paper before you take your next test or quiz. Remember, we are given a chart which describes the rate of change of f for given intervals. And for part A, we want f itself to be increasing and concave down. Let's start with increasing. If f is increasing, then the rate of change will be positive. But we also want f to be concave down, and if f is concave down, the rate of change will be decreasing. So on what interval is the rate of change positive and decreasing? That's the interval from 2 to 3. So using an inequality, we can say 2 is less than x, which is less than 3. Or we could use interval notation and say the interval from 2 to 3. Part B. On what interval is f increasing and the graph of f is concave up? If f is increasing, then the rate of change will be positive. If f is concave up, then the rate of change will be increasing. So, on what interval is the rate of change positive and increasing? That's the interval from 0 to 1. Which can be written as an inequality or using interval notation. Part C. On what interval is f decreasing and the graph of f is concave down? If f is decreasing, then the rate of change will be negative. So we are looking for where the rate of change is negative, and we want f to be concave down. And if f is concave down, then the rate of change will be decreasing. So on what interval is the rate of change negative and decreasing? That's the interval from 3 to 4. Part D. on what interval is f decreasing and the graph of f is concave up? If f is decreasing, then the rate of change is negative. And if f is concave up, then the rate of change is increasing. So on what interval is the rate of change negative and increasing? That's the interval from 1 to 2. So that's it for number 2. Number 3, the table describes the behavior of a function f for selected intervals of x. Part A, on what intervals is the rate of change of f decreasing and positive? Notice that on the previous problem, the table described the behavior of the rate of change of f on given intervals. But for this problem, the table describes the behavior of the actual function f itself for various intervals. One day you will have this chart memorized so thoroughly that you won't even need to write it down. But for now, I want you to write this from memory on a piece of scratch paper to use it on problems like this. We want the rate of change of f to be decreasing. If the rate of change is decreasing, then f itself must be concave down. So f is concave down. And we want the rate of change to be positive. If the rate of change of f is positive, then f itself must be increasing. So on what interval is f concave down and increasing? That's the interval from 3 to 4, which can be written like this or using interval notation. Part B, on what intervals is the rate of change of f increasing and positive? If the rate of change is increasing, then f itself is concave up. So we need f to be concave up. And if the rate of change is positive, that means f must be increasing. So on what interval is f concave up and increasing? Well, that's the interval from 1 to 2. By the way, you don't have to write this both ways, just write it whichever way you prefer. Just be able to recognize either version as an option on a multiple choice question. Part C, on what intervals is the rate of change of f decreasing and negative? So if the rate of change is decreasing, that means f must be concave down. So we are looking for where f is concave down. And if the rate of change of f is negative, that means f itself must be decreasing. So on what interval is f concave down and decreasing? That's the interval from 4 to 5. Kabam! Part D, on what intervals is the rate of change of f increasing and negative? If the rate of change is increasing, then f is concave up. So we are looking for where f is concave up. And if the rate of change is negative, that means that f itself is decreasing. So on what interval is f concave up and decreasing? Well, that's the interval from 2 to 3. Kabam! Number 4. Water is poured into an empty vase at a constant rate. A graph, not shown, models the depth of the water in the vase over time. The graph can be described as follows. The graph is always increasing. The first portion of the graph is clearly concave up, and the next portion of the graph has a fairly steady and steep increase. Which of the following vases is appropriate for the context described by the graph? Think about how the width of the vase affects the rate at which the water rises. For example, At places where the vase is wider, the water will rise more slowly. When the vase is narrower, the water will rise more quickly. We are told that the first portion of the graph is clearly concave up. Here is a graph of the depth of the water over time, and I've drawn it so that the first portion of the graph is clearly concave up. If a function is concave up, then the rate of change is increasing. Remember, this function is the depth of the water over time. So if the rate of change is increasing, that means the water is rising more quickly. But that means that the bottom of the vase is getting narrower as the water rises. So let's look at these four options. Which of these shows a vase where the bottom is getting narrower at first? We can eliminate options C and D because both of these vases get wider during this first interval as we begin to fill the vase with water. Vases A and B both get narrower during the first interval, so we have to use the other part of the description to choose between them. The next portion of the graph has a fairly steady and steep increase. The steep increase means that we're talking about water rising quickly. So we should be looking for a vase that has a narrow opening at the top. The steady part means that there shouldn't be much of a change during the last interval of the fill. So, which of these vases has a narrow opening at the top without much change going on at the end? I think you will agree that option B is the vase that best fits this description. It's more narrow than vase A, and even though it widens a tiny bit, it's pretty steady, it's pretty consistent in its width in the second interval. Whereas in vase A, it's getting much wider in the last part of the fill. In other words, vase B is the only one that gives us this increasing rate of change at the beginning and then a steady and steep increase at the end. Number 5. A rock is thrown off a roof to the ground below. The height of the rock in feet at time t seconds after it is thrown can be modeled by the function g, given by g of t equals negative 16t squared plus 12t plus 32. Answer the questions below, including units. This problem is calculator active, so let's go ahead and type this equation as y1 in our graphing calculator. As before, we will have to use x instead of t. So you should have it typed in like this. Part A, what is the initial height of the rock? We don't need the calculator for this because the initial height of the rock is going to be the height at time t equals 0. So g at 0 is what you get if we just plug in 0 for t, which will be 32. What are the units? Feet. So that's it for part A. Part B, how many seconds does it take for the rock to reach its maximum height? To the calculator for this. Before you graph, you always need to adjust the window. The height of the rock is initially 32. So we know it's going to go higher than that. So we need to adjust the y max to be higher than 32. Let's go with 50, which will probably be fine. I'm not exactly sure what the maximum time it needs to be. In other words, how long before the rock is going to hit the ground. I'm going to just set that at 6 seconds. You can leave your x min and your y min at 0 because the time will not go into negative time and the ground is 0. We won't be going below that. So let's hit graph and see what we've got so far. Okay, this isn't bad. We don't need this much space, it turns out, in terms of time. The rock seems to hit the ground a little short of 2 seconds. So I think I will go ahead and adjust that x max to 2. Okay, and a lovely graph it is. We want to find the maximum height reached by the rock, so we will hit second trace, maximum, option 4. When it says left bound, move the pointer somewhere to the left of the max. And hit enter. Now it says right bound, so move the pointer to the right of the max and hit enter. For guess, move the pointer about where you think the max is and hit enter. So there it is. The maximum height reached is 34.25 feet, and this is the time when it happened. Part B is asking how many seconds does it take for the rock to reach its maximum height, so it's the time that we want. In AP Precalculus, you need at least 3 decimal place accuracy, and you are allowed to either truncate or round. That means you can either cut off your answer and write 0.374 seconds, or you can round and put 0.375 seconds. So that's it for part B. However, I think we are going to need this value later for part D. To avoid a rounding error, I don't want to use this rounded version of the answer. I want to use all of the many decimals that we saw on the calculator. So let's store this value with all of its decimals into a letter on the calculator. So to do that, go ahead and quit out of here. Hit second quit. And now I want you to hit X and then the store button and then choose what letter you want to store it in. I'm just going to use letter A. So let's do alpha A and hit enter. Now all of these decimals are stored in letter A. Part C, what is the maximum height reached by the rock? Let's peek at that graph again. The maximum height was 34.25 feet. Part D, how many seconds after reaching its maximum height does the rock hit the ground? We already found the time at which the rock reaches maximum height. We just need to find the time at which the rock hits the ground. So we can subtract these two values to answer part D. The time when the rock hits the ground will be the 0 of this graph. There are 2 ways to find this 0. You can either hit second trace and choose option 2 for 0, and then this sets up a whole left bound, right bound thing. Or, and this is my preferred method, you can graph the x-axis itself by putting a 0 on y2. That's why you see a red line here on the x-axis. This way we can just find the intersection point between the curve and the x-axis. This is quicker because there is no left bound, right bound menu. So hit second trace, intersect, option 5, and just move your pointer close to the 0. And just hit enter 3 times. And that's it. The rock hits the ground at 1.838 seconds. To find how long it took for the rock to hit the ground after reaching its maximum height, we need to subtract these two values. However, to guarantee accuracy at the 3rd decimal, I don't want to use these rounded values. So we already stored this number with more decimal place accuracy into letter A. So let's store this value into letter B and subtract B minus A. Let's practice storing this X value into a letter. Quit your way out of here, hit the X button, hit the store button, and pick a letter. Let's use letter B. So to find the difference between these without using the rounded values, we can now do B minus A. So we will do alpha B minus alpha A. So the answer is 1.463. Yes, in this particular case, using the rounded values gave us the same answer, but that will not always be the case, so I suggest storing your letters and using all of the decimals like I taught you. Don't forget the units. Number 6. Part A. Which function has a rate of change that is positive and decreasing? Let's use this chart one more time. If the rate of change is positive, that means the function needs to be increasing. If the rate of change is decreasing, that means the function is concave down. So we are looking for a graph that is concave down and increasing. So the answer to part A is j of x, because this is concave down and it is increasing. It is rising from left to right. Part B. Which function has a rate of change that is negative and decreasing? If the rate of change is negative and decreasing, then the function itself must be decreasing and concave down. The function that is decreasing and concave down is f of x. So that's the answer to part B. Part C. Which function has a rate of change that is negative and increasing? Let's see if we can kind of do this from memory. If the rate of change is negative, that means the function itself must be decreasing. And if the rate of change is increasing, that means the function must be concave up. So we are looking for a function that is decreasing and concave up. That would be h of x. See how it is falling from left to right, so it is decreasing, yet at the same time it is concave up. So h of x is the answer to part C. Part D. Which function has a rate of change that is positive and increasing? If the rate of change is positive, that means the function itself must be increasing. If the rate of change is increasing, that means the function must be concave up. So, which function is increasing and concave up? That would be g of x, increasing and also concave up. So g of x is the answer to part D. Hey guys, don't forget to like and subscribe. But also, if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.